All right, and we're back. Literally, I just pressed stop and I pressed play again. Okay, so let's go back over what we were looking at. We were looking at inheritance very briefly. I want to look at this public, private, protected thing. I'm doing this, revisiting it now because, frankly, I could not really get into the gory details of this before because of this one right here, this protected. I could not really describe that until I hit inheritance. Public means everyone gets access to it. If it's a variable, everyone has access to it. It can change your variables on you. If it's private, only that one class has access to it. Nobody else, or friend classes do too, but I don't use friend classes very often. Protected's the weird one. Protected means myself or my children, my child classes have access to that data or that particular method. Not everybody and their dog, just me and my kids. So, public, we proceeded with a class member. We put public, if we're talking about class member variables, if I put public at the beginning, it's accessible to anybody from any function, anywhere. If I put the name public in front of the class, it means everyone can see the class no matter what, no matter where. And all the derived classes and stuff like that would also be public. Private member variable, so anything that is public, everyone can see it. Private, if I make this thing private, it means anything that I make as a child class is not visible. It gets really kind of weird really quickly. Private means only I see it. Private keyword specifies that members are accessible only to the member functions and friends of the class. So in the class you can see that variable, otherwise you don't see squat. The friend keyword is one of our workarounds, but a lot of people, myself included, try to avoid using the word friend. The word friend means you give somebody else full access to all your data, and it sort of breaks some of the coding conventions that we have. If we put the word private in front of the base class, it means that public and protected members of the base class are private for everything. So all the private members of the derived classes. So if I make a derived class, so let's say doubly linked list. If I have the word private at the top, it means the base I can derive that class. So I make doubly linked list. Doubly linked list does not have access to the functions or the variables associated with the parent class. I have this parent class. It does stuff. I have no idea what they do. It's kind of strange in that way. I don't happen that often. For the vast majority of time, I am a big fan of keeping it simple. I have not come into contact many times ever with private classes and protected classes. I have come into contact a lot of times with protected and private variables, protected and private functions, but the class themselves, that's a different beast. Okay, so private means only I see it. No one else sees it, it's only for me. If we have a list of class members, the private keyword specifies I can't believe every single time the protected. I think I found this problem last year and I still didn't see it even when I go over my slides again. The protected keyword specifies that members are accessible by the following. So any child class of mine. Member functions of the class that originate are declared in these members. Friends of the class can see these member variables. Classes derived from with a public or protected access can see those variables. Derived classes can see those things. It's hard, this is going to be a little bit wonky and weird to talk about. I want to talk about the protected, private, and public keywords outside of the class, predominantly aiming at the functions and the variables. So, and when I have protected, when proceeding in front of the base class, protected keyword specifies that the public and protected methods of the base class are protected members of the derived class. Essentially, protected on the class means everything in the class is protected. Private in the class means everything in the class is private. Public in the class means everything unless specified. And public in the class means everything inside, well, theoretically could be public. Protected members are not as private members. So if I have a private class or private variable, it is not as private, as you might imagine. It means my child classes can see it. So this is, I like to point out this, makes access more restricted or keeps it the same. So every time I have another level down, so I have a public class and I have a public inheritance, it means everything's public. If I have the base class is public and then it's protected, then everything in the base class is protected. If I start with protected, it has to be, and I go public in the inherited class, then everything is protected. Essentially, as I go down a level, it will take whatever my base class had and either make it more extreme or as extreme. So if I start out, if the base class is private, the child class is also private. Even if I call it public, it's private. And I can't access squat, really. If I have it protected, the base class will automatically be protected. We don't really do this very often. Most of the time for classes, we're here and here for our class, for classes in particular. I'm a big fan of keeping it simple. So, for me at least, when looking at this, for the time being, because I'm not going to be grilling you on this thing, when I have classes, most of our classes are going to be public. I want you to know that you can make a private class and everything inside the private class is private. You can make a protected class so that only child classes can see stuff in it. And I also want you to know that if I have a protected class, a child class will automatically be protected or private. It'll be more restricted or equal level of restriction. But I like this in terms of sort of the visual metaphor. So here's what private is, right? Tips on how to enter my room properly, do not. Right. That's really what private is. No one else sees it. It's mine. Don't go in here. Stay the hell out. Right? If you want to give me dinner, fine. Leave it out front of the door. This is like the surly teenager part of computer science. It's everything's private, it's mine. You don't want anyone to know about anything. Protected is like my house, right? Can you randomly come over to my house? No, I'm saying you're not allowed to randomly come over to my house, no matter whether you want to or not. Right? You sure as hell can't walk into my house without without telling me. My family members can. My sons can come and go as they please into my house. Everyone in my family can come and go as they please, but random other people can't. A protected method says myself or my child classes, things that extend from me, know about this data or know about these functions, but not other people. It's only for people in my people in my family. That's what protected means. It's one way of looking at it. So if I want to make sure that I have a variable that only people in my class can look at, or a subclass of mine, like an inherited class of mine, can look at, great, throw it in protected. You don't want that variable exposed to everyone, but maybe other classes, related classes, child classes, should be able to see that variable. Protected. Maybe only we had a protected function in the doubly linked list thing for get start and get end, right? Because not everyone should know that I'm using a LL node or DLL node. They just need to be able to use a linked list. Protected. The only people that need to know about doubly linked list nodes, these nodes, are the linked list classes. The main method, some other thing using my linked list, none of them need to know how I'm actually implementing a linked list. Protected, right? Not private because I have child classes that need access to it, but protected. And here's public. Now, I like to point this, that I like using this example because this is from the Boston Gardens, the Boston Public Garden, not the Boston Gardens, which is TD Gardens, which is where the Bruins play. This is from a book called Watch Out for Ducklings. No one in Canada has ever heard of it. I was shocked and surprised. It turns out it's a huge, sort of famous book. It's like Goodnight Moon for a lot of Americans. It is a book from the 1940s, I do believe. Takes place in Boston and Cambridge, where it is a mother duck having a bunch of ducklings following behind her, and the cars and stuff are stopping for the ducks. It's also fascinating to see how much Boston has changed since the 1940s. But this book was a very famous book, and so they have a series of statues, these little brass ducklings and this duck, in the middle of the park. What do you think people do with those ducklings and ducks? And duck, singular, sorry. What do? They ride on them. They stand on them. They spray them with graffiti. They surf on them. They probably pop open beer bottles with them. Whatever the case is, they're public. What happens when you put a whiteboard out in the middle of the hall? People draw penises on them, right? This is what happens when things are out in public. Most people will behave. Some people will not. When you make something public, you better be ready, willing, and able to clean up the graffiti, replace the duck statues that get smashed, or whatever the case is. Those ducks are bolted to the ground because otherwise people would take them. And even then, I'm sure they've had to replace a number of them over time, right? That's what happens when something is public. It's to be expected. If you have a public function, expect people to throw garbage at your function. If you have public variables, expect people to exploit and change your variables on you whether you want them to or not. If you don't want them doing that, don't make them public. Period. That's the way to look at this, hopefully. So private is you need to protect this. No one needs to know about it. Only you need to use it. Great. Private. Protected is myself or one of my child classes need to use it. And public is anybody can use it. Be careful, right? That's how one of the ways you can look at this. I like pointing out the you can really overcomplicate things. Look at this. Like, this is crazy. I'm not going to ask you what this is. You can really overcomplicate things if you do not need to worry about it. So, for our cases, make the parent class public, make the child classes public. Later on, when you need something different, change it. But for most of our cases, this is just going to overcomplicate things. Making something complex doesn't show intelligence. Making the complex understandable does. I like pointing this out. Any idiot can make things complex. It takes real genius to make something simple and understandable. I do not make any claims that I can make things simple and understandable. When you see it, you go, "Oh, that's impressive." If you make a math proof really obvious to anyone that reads it, that's hard to do, right? This same thing here. If your code is easily understandable, that's good. That's not bad. It doesn't show that you're not intelligent. There's lots of idiots that try to make things complicated thinking that they're going to impress others. It's like using big words in a sentence, right? If you use big words for the sake of using big words, all you're doing is showing that you're trying not to communicate with the other person. It's a different thing. Your job as a programmer is to make the complex understandable, and so if you don't need to make it overly convoluted for no reason, don't. Keep it simple. Let's keep public classes, but private variables, protected and private functions, and maybe some public functions as well. I like I like this quote. Everyone knows that debugging is twice as hard as writing the program in the first place. So if you're as clever as you can be when you write it, how are you ever going to debug it? That has bitten me enough times to I can swear to that particular quote, right? I tried so many like, oh, this will be so cool to code it this way, and then you try and debug it, and it's a slog. Keep it simple as much as you can. You want to make it understandable, and the reason we have this public, protected, and private thing is to keep it simple for you. It's not for and to make it safer. So you don't make everything public because it makes it harder later. Other people can change your code. But you don't put extra weird stuff in your code for no reason. If I make something private, it means only I can use it, and now I don't have to worry about weird side effects of other classes stomping on or changing my variables. It protects me from myself. By making it protected, it means if I have a problem with that piece of code, I know the only cause of that problem is myself or my ancestors. If I have a problem with a piece of private data, it's only caused by me. No one else could be doing that. If I make it public, don't know who's causing the problem. That's why we do it this way. It's to protect you from yourself. So, just like, you lock your doors, not because you don't like everyone else in the world, but you do not want to make it easy for people to break into your house, right? In a similar way, I make things public, protected, or private just to make it harder for people to exploit my system. makes it easier for me to understand the world, but I don't need to overly be paranoid about it. I don't need to make things overly complex. This helps simplify my code. That's what it's there for. Not to make it a big, more of a pain, but to make it less of a pain. Okay, so last time around we looked at this, constructor and destructor order. We actually looked at this with doubly linked list. Here's the weird thing about linked lists. So if I'm going to make, and I have a little image, I think, oh, it's way the heck down there. If I'm going to make a new object, I'm going to just draw a picture here. So if I'm going to make a new object, what do I need? So let's say this is my doubly linked list, right? I have my linked list in the center, my doubly linked list on the outside, right? This is my metaphor that I'm going to show a little bit later on as well. Looks like a Pokeball, actually. So I have my linked list in the center, my doubly linked list, the extra stuff that I'm adding to it on the outside. When I'm making a doubly linked list, what do I need? Well, if I make the outside part, do I know I have everything right? What I really need to do is make the inside. Constructor is make the inside and out for the constructor. I need to start with the germ, the center part, and then I build a layer on top of that. When I destroy that object, I don't know when I'm going to destroy the center part. So for destruction of the object, I go outside in. I need to destroy, so destructor is this direction. I need to destroy the outside layer and then destroy the inside layer. This is the only way that constructors and destructors will work. Let's quickly have a look at, hopefully I have this here, and a linked list, and let's run it again. There you go. I call my constructor for linked list. I call my constructor for doubly linked list. After I'm done, I call the destructor for doubly linked list, and I call the destructor for linked list. This is exactly what I said we had to do. We have to do it in that way because I'm getting rid of functions, and I'm getting rid of variables, right? So if my function or my variable, let's say some variable of mine on the outside relies on something on the inside, right? If I have to call some particular function in my destructor and it uses an internal variable here, what happens? I'm host, right? If I'm using that in the destructor, this variable has to exist. So I have to make the variables and the functions for my internal class before I call I need to destroy it after I destroy the outside class, because otherwise I may have cases where I say, oh, clean up this thing, and it's already gone. If I'm going to, so let's say set x or set previous or set next, right? If that function goes away, set next is in here. If this destructor calls set next and it's already destroyed, I'm calling a function that doesn't exist. Bad stuff's going to happen. The only way I know how to do this is if I tear down and set up the same way. It's in these sort of the opposite directions. So I like thinking of it like setting up a table. When I'm calling a constructor, so when I make a brand new object, what's going to happen? If I'm setting up this table, I cannot lay down the dishes first. I have to put down the tablecloth first. Then I can put down these dishes. Then I can put down these dishes. Then I can put down these dishes. It's layered on top of each other. I can't put all of this stuff, like these candles and the pumpkins and whatever crap they have on this table. This is way too complex for me, right? All of this stuff on the table, I gotta put down the tablecloth first. That's the base class. First thing I do is I put down the tablecloth. The last thing I do, unless I'm a magician, the last thing I do is take off the tablecloth, right? After I put down the tablecloth, then I can put stuff on top of the table. The base class constructor has to be done first because otherwise I can't do it later. Putting this stuff on the table relies on a tablecloth being beneath it. And when I'm clearing things up, when I'm destructing, when I'm destroying everything, when I'm passing things back to the system, I take these plates off the table, then I take off the tablecloth. When the base class constructor is called, the derived class does not exist yet. That's a weird thing. So I make the base class, so I put down the tablecloth. I do not have any plates on the table yet. Nothing else is on the table, just the tablecloth. That's when I call my base constructor. And so if I call a function involving the base constructor, it's going to be something involving the base, not any derived classes. After that, then I put on the derived classes. I build the derived classes. And then because otherwise I might call my derived class, like the doubly linked list, might call setNext. SetNext is not set up unless the base class is done first, right? So we have to do the base class first, then derived classes, so the parent, then the child, then the grandchild, then the great grandchild, whatever the case is. It goes in order from the parent to the child in terms of constructors. And for destructors, it goes from the great grandchild all the way up to the parent. And it has to be that order, otherwise bad things are going to happen. So I have classes B and BB. We've already looked at this a little bit. We have a constructor for B. In B, I call bar. The original version of bar has to be executed. BB does not exist yet, so I make some class BB. So first things first, I call the constructor for B. But BB has not been created yet. The very first thing I do is make the base class. And so if I call bar, I'm calling B's version of bar. After I'm done with the constructor for B, then I start making BB. If I call bar again, I'm going to call BB's version of bar. And so what you end up getting is this weird effect that you have to know the order of things. So if you go back to that previous example earlier, like a couple lectures ago, you'll see this in action, where I will call B's version of bar, not BB's version of bar, because BB doesn't exist yet. I do not have that function yet. It hasn't been created yet. Afterwards, if I call bar, I'll call BB's version of bar for free instead of B's version. Okay. When I'm destroying things, I got to work in the reverse order because I cannot, if I have to do some cleanup of P start, for example, I need to make sure P start actually exists. So I go from the great grandchild or the lowest level function, the first child, and then I go up the chain. It's a reverse order. It's called a derived class first, then it goes up to the parent class, and then parent to the parent class. And it has to go all the way up this way because I don't know. I'm removing and giving back memory. And since my parent class does not know anything about the child class, right? Your ancestors did not know anything about you. Your great 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 grandfather does not know anything about you. I'm sorry to say, but I'm pretty sure your great 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 grandfather is dead. Does not know that you exist. So, if you're thinking it that way, right? They have no idea about their sub child classes. So the only thing you can do is deal with yourself. You'll know about your parent class, but you don't know about your child classes. You can't know about your child classes. It's designed that way. And so you have to do it, the destructor, in that order. It happens for free. You don't have to even worry about it. If you look at my doubly linked list class, I don't actually explicitly call the parent destructor. It just happens for free. But you need to know that it's doing that so you don't have these weird cases where you give back something to the system and then you find out that you couldn't do that. You will automatically, for free, call the parent's destructor. Just like you will automatically, for free, call the parent's constructor. So, if I want to make an explicit call to a particular constructor, then we'll do you can actually see in the doubly linked list class or the DLL node class. By default, we have a default base constructor, which is it takes in nothing. But otherwise, we need to give it an explicit constructor. We need to say, no, I want this constructor. So here is me. Whoop. I'm going to make this constructor. So here's here's a base constructor. It does nothing, right? It's going to automatically call this base constructor over here. So here's a constructor 1, constructor 2, constructor 1, constructor 2. This thing is going to call this one by default, just because that's the default is always the blank one. And this one is going to call this one right here, because I'm explicitly stating this one. the one that takes an integer I. It takes an integer, so the one that takes an integer is the one I want. I'm going to call that constructor instead. So here's what's going to happen. BB, when I make a new, so let me see here, public class BB, here's my constructors. Okay, I'm not actually doing the call here. If I make a new BB with an integer, it's going to go call this one, immediately call this one first, make a variable B, go back here, finish the rest of this stuff. If I make a new BB without a parameter, it's going to call this one, go this one, call bar, and then come back. So new BB means I'm going to call 1, 2, 3. Start here, jump over here, call bar, jump back, finish my constructor. This thing here, if I call new BB value 4, it's going to be A, B, C. It's going to start here, immediately jump over to my constructor, do this, set the value for B, then jump back afterwards. So if you want extra practice, and I strongly recommend it, try some other things out. I think this is going to be related to a future assignment, assignment 3. At least that's the plan right now, right? If I have a media library, or if I'm talking books, or I don't know if you know what this is. It's called an audio CD. I know, crazy. Before streaming, they used to have these things that spun around at high speed and had a laser. Sorry, a lot of my kids keep on like, "What's a CD? Why do you have these CDs in the house?" If I wanted to organize my CD collection, or maybe I have a bunch of different types of discs, a CD disc, audio disc, CD data disc for like a computer back when they used to use those, and a DVD disc, all look effectively the same. They're all stored in the same kinds of cases. So maybe I want to be able to differentiate them. So I have a disk class, and then I have a child class, which is CD audio, a child class is CD data, and a child class is CD video. Maybe I have a bunch of books, and different types of books, and different genres of books. Maybe I have book series and not book series. Maybe I have newspapers and magazines and different kinds of periodicals. You can make any kind of class you want. This is one of those ones that you can play around with a little bit. Try making your own, right? Try to make a class that does these sorts of things, and start from scratch and see how it works. That's actually, by the way, the exam question last term was, I do believe it was a library and people taking books out of a library. That was the coding that they had to do for the exam. It won't be that exam again this term, but that's the kind of thing we can ask on, right? Come up with a data structure like a library book that allows you, that has an ISBN number that allows you to take out and check in books. And so you'd have a library, you'd have people with a library card with a unique ID on their library card that take out books, and how those things all interact with one another. And if I want a particular kind of book versus another, do I make a child class of that for this kind of book versus that, right? You can come up with your own examples without necessarily having me give you one particular example. Try it out. See how you do. So the DD demo is in the shared folder. Also, I think I'm going to pass along the book demo as well, just so you can see it, but I'm not going to go over that in details. Just another example you can look at. But you can look at how the constructor and destructor call is being done. If you're not sure, code it up, test it out, right? If you take my code for DD doubly linked list, the doubly linked list demo, and you just play around with it and change it, go right ahead. Try adding a whole bunch of nodes to the doubly linked list and then just deleting the doubly linked list and see if the destructors get called. Make a dynamic doubly linked list, see if the destructor is called. Make a dynamic doubly linked list, dynamic doubly linked list and explicitly call delete. Try things out if you don't understand something and see what happens. The compiler will tell you what is happening and you will understand. It'll be a lot clearer than me telling you. Okay. I also like to point out this particular metaphor, and this is what's going to lead us to our next topic, which is polymorphism. So here is one way of looking at it. This is our doubly linked list, or DLL node. So this is DLL node. We have get next, we have print. I think we have a print method at least for this. We have next variables, a variable, a private variable called pnext. We have a private variable called pprevious, right? So in this class, if I'm in this right here, I can use get next, but these functions on the outside for doubly linked list node have no access to nest, right? It's inside this shell, right? This shell around here prevents anything but private variables to look at this. So if I want to go one step further, pnext has complete access to this, right? Inside linked list node, getNext has access to pnext. I have no access. Oh boy, did I go? There you go. I have no access from outside of this class. There's absolutely no way I can directly access those variables. They're private variables. Exclamation point. All right, they're private variables. I cannot directly access those variables. They're private. I can. This is the function print is a public function. The functions getNext and getPrevious are both protected functions within the class hierarchy from either doubly linked list or linked list. Doubly linked list node or linked list node. I still have access to getNext and getPrevious. Outside of this, nope, no access. Public methods outside of the class, I can access it. Protected, nope, I can't access it. Private stuff, it have to be within the same one class. I can't even be in a child class of it. I can't see it in a child class. For protected methods, I can see this is a protected function. I can see within the child class, but I can't access it outside of a child class or inside from within outside the class itself. So what we have is we have our original object, and then we wrap more stuff on the outside of it. And our access to it depends on if it's protected, private, or public. And if it's private, I can only see within the class. If it's protected, I can go from the outside in, but I have to be within this green region somewhere. And if it's public, anyone has access to it. That's the metaphor that we're playing with. So again, these are all now work. Oh, but I wanted to point out one other thing. Here is public. What if I redefine print? That's where we're going to get to next. If I define print in DLL node, right out here, let's say, what's going to happen? So I have a definition of print here, a definition of print right here, and then some outside in public, I call print. What's going to happen? This is going to happen. I'm going to hit the outside version of print first before I get to the one on the inside. This is just a visual metaphor, but I will go to the child version of things first. And then if there's no child version of print, then I will go further in. And if there's no version of print there, I'll go further in until I finally hit some function named print. I will get the outermost instance of that function. If I have pprevious and pnext, or let's say I have a pnext down on the way out here, and it's public, I will get the pnext on the outside first. I go from the outside in looking for things. So if there's a print before I get to the center, I will use that print first. That's what we're going to get to next. That's what gives us polymorphism. Polymorphism means I can have two versions of a function called print, and I choose the right one depending on what my class is. And that makes a huge difference to how coding works. We'll get to all the weird subtleties of this very, very soon, but I just want to expose you to this first. If I don't have another print, I'll call the one in the center. If I implement print a second time, I'll call the outside one. As long as I know I'm dealing with a doubly linked list node, I'll call this outside version of print instead. If I have two versions of print, one print that says, has a parameter, one that doesn't, I'll call the one that has the parameter, or I'll call the one that matches the best. Okay, so let's go over some basic coding errors and then we'll stop and take a break. So one of the common compilation errors when we have a derived class constructor calls with one of the base with the base class constructor is not the correct arguments. So we've actually seen that in the example I gave last time with the live coding. I was calling a constructor with an integer, but the inside one, the base class, used a DLL data or whatever the heck the structure was instead. It wasn't using an integer, it was using a different type of variable. And as a result, different constructor, different kind of data, the arguments were different, and therefore it couldn't find it. If I have multiple inheritance, you will cry. So just letting you know. So we have an electric car. Is a so if that's a subclass of car, it's also a subclass of electric vehicle. I could have an electric vehicle as a class. So we have vehicles in general. We have electric vehicles as a subclass. We have car as a subclass, a different subclass of vehicle. What's an electric car? It's a subclass of electric vehicle and of car. So what if I have the same name or the same function name in both of those classes? What if I have a drive function in both of those classes? Which parent? So I have, let's say, we have a drive function in both of those. We do not implement the drive function. So here we go. Here's the drive function. Here we go. Another drive function. Here's what's going to happen. If I haven't defined drive in electric car, what's going to happen? Which one of those drive functions do I call? Do I call the electric car's version of the drive, or do I call the car version of drive, or the electric vehicle version of drive, or do I call the car version of drive? This is where multiple inheritance can make you cry. These are the kinds of, that's why some languages don't allow multiple inheritance. Okay. Do not guess with public, protected, and private. You will. Everyone does at some point in time, but try not to, I guess. Like, a lot of people will just guess and they'll make everything public and hope for the best, and yeah, it's good enough for passing in the assignment. That's because you didn't work ahead on your assignment early enough. What you want to do is, I know I'm making this public because I need it to be public. I know I'm making this protected because I know my child class needs to know about this variable or needs to know about this function. I'm going to make this private because only this particular class needs this function or variable. If you make it all public, you should lose points on your assignments. You will definitely lose points on any exam question that I'm grading on this. Making everything public just gives everyone keys to the car. So, and also one of the big common things like set X, set Y. Oh, well, let's also let's use my mistake from last time. I forgot the word public in my classes, and as a result, everything was by default, by the way, protected, not private, but protected is the default under the hood, right? And if we have different file names, so this will come. We have the this pointer we had as a problem, right? Local variables versus member variables, and we have things like if I have set x and set x, two different versions of set x, different names, one in the child class, one in the parent class, they will not be considered the same thing. It will not give you any mistake. It will not say anything's wrong, and will merrily let you screw yourself over because you will not see the difference of a capital X versus lowercase x. As long as you're consistent, you want to make sure that you're replacing, the child class is replacing the parent's version of that function. As long as you're consistent, you won't run into that problem. But that's why we have a consistent naming scheme for our functions, because we don't want to get into those problems. Okay, our base class header file, so you should include all your derived class. So the base class header file must be included in all the derived classes. And if you don't, so when I have a doubly linked list node class, it needs to include the linked list node header file, so I know that it exists. This is going to come to you for free but it's something to bear in mind, right? And if you're not sure about what to do with your header files, one approach is throw all your header files in one file, one master header file, and then have all of your CPP files include that one header file. That's one workaround in case you get into trouble. Okay. Um, One way you can go about doing this. So Ali likes doing public first, protected second, and private last. I also like doing that because people are going to stop reading your file after a little bit of time. So they'll only be seeing the public stuff first. So have some reason, have some structure to how you put and your functions together. But normally it's public at the top, protected in the middle, private member variables and functions at the end. Uh, it's essentially the order that programmers need to see your stuff. You can also group your functions together based on the type, so all your getter functions together, all your setter functions together, all of your paint methods together, that sort of thing. You just want to have some rhyme or reason to your structure to make sure that everyone can follow along and that you can find it later. Um, in terms of protect data, what are the advantages? Well, one of it is just keeping you sane. Um, I do not like this, so let's just. Eh. One thing you could do is instead of using get start like I was doing, you could just have a protected piece of data and then you could just directly get that piece of data versus having to go through a method. It is a little bit more time consuming to call a method instead of just directly getting the data. But if you do that, there's no validity checking. You can just stomp on or change the data some other way. There's nothing protecting. The child class can do all sorts of stuff to the parent class without the parent class being wise of what's going on. Uh, and the derived class, this child class, is dependent now on how things are done in the parent class. If you go through a function, you can change the parent class and you'll be none the wiser. So there's some benefits to that. Uh, it is appropriate to use protected access specifiers when a base class should provide a service uh, and not provide it to other people. So protected is you're providing some kind of service. You don't want everyone having access to how things are implemented. Go ahead and use protected. That's the appropriate time. You want private as opposed to protected. It allows programmers to change the base class without having to worry about what other people are doing. So I like to point out that the vector class in C++, I have no idea how it works. I've extended vectors. I don't need to know how it was implemented. I just can use it. You can only get that if you don't have to worry about if you're getting direct access to public data, you can't do that anymore. The idea is that if you encapsulate, if you hide how things are implemented using public, protected, and private, it allows you to not have to worry about people doing stupid things to your data. My personal favorite example of this is, let me see here. So Google has, at the time when I was there, and it's much bigger now, at the time when I was at Google, it had 500 billion, it can't be that much, 500 million? Half a billion, yeah. Half a billion lines of code in their code repository. No single person at Google knew how everything worked. In fact, at Google Newsstand, just a small app in this large, huge ecosystem of all of Google, not a single person knew all the entire code base. If you do not make modular code that people do not need to know how it's implemented, but just need to be able to use it, if you do not make modular code, things can't scale. Our software engineering nowadays is reliant on being able to take a widget and just use it and not have to worry about how it's built. Because if you have to worry about how it's built exactly from the ground up, it's a futile effort. It's too much for any individual person to do. That's the reason we have this particular approach. It's to protect you from yourself and allow you to scale at a much larger scale than you could otherwise. We want little modules, little things, little doodads that do a job. And that requires using private and protected variables, because if everything's public, then some other function somewhere else can just stomp on the data and you'll have a hell of a time tracking down what caused that problem. That's why we do what we do. It's to be lazy, efficiently lazy. Okay. Um, when possible, avoid including protected data members in the base class. Well, I don't know about that, but non-private members are somewhat very similar to predicted. Yes, there is a slight difference between the two. I'm not going to be asking you the difference between the two. You just want to, for me, the big thing is use getters and setters. Those are your friends. It'll take you 2 seconds to write the getter and setter methods, and it will save you hours when debugging your code later. Use getters and setters. Make sure not everything is public, and think about how your code is designed rather than just barreling into a bunch of code and hoping for the best. Keep it simple, stupid is the big thing to always worry about, right? You can easily outthink yourself and get yourself into all sorts of trouble. Um, if you use member variables, functions to access member variables, it is slightly slower, but it means that, and I'm pretty sure optimized compilers nowadays will actually make it optimally efficient. It'll make it just as fast as directly getting the variable, but it keeps you from shooting yourself in the foot. So one of the big things is, even if you're worried about the speed of how your code is working, some of you might, most of you won't. The cognitive overhead, the amount of thinking you have to do to get all cutesy with your code, kills any improvement that you're going to make. So you might as well have a rigorous approach to how you design your code, which involves getter and setter methods, keeping things protected, keeping things private. Okay. Uh, Other languages, by the way, have the super keyword. We do not have the super keyword. The super keyword allows you to call the parent class on some things. So if I'm in uh, the print method for one thing, I can actually call. So I should be able to do this. Print some, and then some stuff. And then I should be able to go colon colon. I can explicitly call the parent's version of that particular function if I want. In Java and some other languages, you call super. In this case, you just say, you have to explicitly state which class, which parent class that you have, and the function name itself. So it can give you a little bit of extra work involved in there. We're going to make inheritance work, but one of the problems we had is when we're calling, if I have an array of linked list nodes, remember how ugly it was when I was casting linked list nodes to doubly linked list nodes everywhere? We won't have to do that very soon, the moment we hit polymorphism. So I've left a couple slides in there if you want to look over. They're not covered in the course, but when we come back next time, we're going to be looking at polymorphism, allowing us to call the right function at the right time without having to worry about, oh well, this is a subclass of this, making it so things magically work for you. And once that we get that, hopefully all of object-oriented programming will make sense of why it's so powerful and why it's so important to what we're doing. All right, thanks everyone, and I will talk to you soon.